Okay, y'all, I wanted to sort of remind you and go over, I wanted to go over the concept of the scientific method one more time and really kind of talk a bit more about the controlled experiment. So if you recall, the scientific method has quite a few components that are flexible and that the entire method itself is flexible, that it's not, it's able to be changed depending upon the type of research. So, of course, any good science begins with observations. We know that. We observe the natural world around us. And if something is amiss or something that we're not expecting occurs with our observations, we tend to then pose a key question, wondering or asking why, okay, or how. And so this kind of goes back to that whole, what I've been kind of talking about is that our observations are drawing our attention to the what things are, and what they're doing. And the key question is asking how or why that occurs. Okay, so when we come up with our key question, that tends to lead us to what the book has been defining as an educated guess, or as what we'll call here our hypothesis. I think everyone's okay with this idea as far as observation key question. That leads us into a hypothesis, and in that hypothesis, we have to be able to test that hypothesis. We have to show whether or not this hypothesis is right or wrong, or more importantly, what we've been talking about is this hypothesis falsifiable? Because a hypothesis that can't be falsified, in other words, if the hypothesis is constantly giving us the results that we expect, and nothing is wrong and nothing is fallible, and we can't show that this hypothesis is false, it gains more credibility. And the way that we test this hypothesis is with what we call the controlled experiment. And that's what I want to talk about, and just not really lecture on you, but to show you the details to sort of remind you on how to remember what a controlled experiment really is. Okay, so remember, we kind of defined the ideas that there's this 3, 2, well, that's just terrible. I guess the smartboard doesn't like to work over there as much. There's that whole 3, 2, 1 of a controlled experiment. There are 3 variables, 3 types of variables, 3 types of variables, split into 2 groups in one controlled experiment. If you guys recall that, if you can count that, the 3, 2, 1. All right, so let's talk about this. What does that mean in terms of what are our 3 variables? So the first type of variable we know to be the independent variable. The second one is the dependent variable. And everything else that doesn't really have to do with either the independent or the dependent variable are called controlled variables. Okay? Remember that the dependent variable is what the independent variable is what the scientist manipulates. Okay? So like when we were talking about the diet dog food, that would be giving the dogs dog food, or the diet dog food. Sorry, I should have written, I don't know why it did what it did there. Okay, so the independent variable, what the scientist is manipulating, would be the diet dog food. Okay, so we've got the diet dog food as the independent. The dependent variable is going to be what we measure. We're measuring an expected change. So the dependent variable is dependent upon the independent variable, and that shouldn't surprise us. That's what we call it, the dependent variable. In our example here, it would be the dog's weight. Now, that's all well and good. So, diet dog food is our independent. We're going to give the dogs diet dog food, or dog food in general. The dependent variable is going to be whether or not the dog's weight changes. Really, we could specifically, when it comes to the independent variable, it's just going to be, instead of the diet dog food, it's the type of food. Okay, obviously here we're testing the type of diet dog food. Now, what does it mean to have a controlled variable? Controlled variables are going to be all of the other variables in the experiment that have really nothing to do with the dependent or the independent variable. And there are multiple controlled variables. Some examples of, in this case, of a controlled variable would be type of dog. We can't compare Doberman Pinschers to Chihuahuas, so we have to have the same type of dog. Okay? The number of dogs. We can't compare 20 dogs to 4 dogs, so the number of dogs needs to be the same. The amount of water. What if the different type of the dog or the different numbers of dogs or the amount of water causes a change in the dependent variable? Then anything that our independent variable could have shown will be blocked by not keeping these other variables controlled. So the amount of water, the bowl that the water comes in, cage or area that the dogs are kept in, the temperature where the dogs are. All of those are controlled variables. So how do we take these two types, or these three types of variables, and put them into two different groups? And that's what I'm going to show you now. Well, I thought I was going to show you. I thought I was going to do a split screen, but I don't think I can do split screen. Oh yeah, here we go. So, how do we get this into two different groups? Well, first of all, what two groups are we going to have? We're going to have, oh, I didn't want to do that. First of all, we're going to have two groups, okay? And remember, they're going to be exactly the same in their controlled variables, okay? Same water, bowl, number of dogs, temperature, etc. Those are the control variables. So the control variables are going to be the same in both groups. In one of the groups, we're just going to call it the control group. The control group is going to have regular dog food. Right? Because we just want to see how those dogs' weight would change with regular dog food. They're controlled. They are not exposed to the independent variable. Not exposed to the independent variable. That leaves the other group to be known as the experimental group. And the experimental group's job is to be exposed to the independent variable. So they don't get the regular dog food, they get the diet dog food. So one group of the same number of dogs, the same type of dogs, is going to get regular dog food. Another group that has the same type of dogs and the same number of dogs are going to get the diet dog food. And remember, both groups are going to have the same controlled variables. The experimental group will have the independent variable, and the regular dog food will not. That means that when we are looking for the dependent variable, we are looking and measuring for the dependent variable to change in the experimental group. We don't expect the dependent variable to change in the control group. The only way that we can know if the independent variable caused a change in the dependent variable, or dog food, is to measure the dog's weight from the experimental group and compare it to the dog's weight from the control group. And so that's the reason why we have a 3, 2, 1 of a controlled experiment. 3 types of variables: independent, dependent, and controlled, split into 2 groups, controlled and experimental, into 1 scientific experiment. I hope that this helps. Please review this as much as you can to make it easier when reviewing the scientific method.